This week on LCARA Ham Radio, we're going to get out the service monitor again and head up to the 88 repeater site. We're going to start tuning the deplexer at that location for 2 meters. And N4 RLS, Ron is going to show us how to use much of the equipment, or at least give us an idea of how the equipment is used. That's what's coming up this week on LCARA Ham Radio. Folks, we started arriving at Worldwide Headquarters there in Munsey, Kentucky, and we had a newish member who had never seen Don and Wanda's amateur radio garage. In a lot of ways, there's a lot of amateur radio gear in this garage, and this is where we do numerous projects over the years, and it's always great to see new eyes look at this garage.
That we actually do document some.
Yeah, one second here while I write.
I'm gonna come around to the other side.
Now you're making me nervous. I'm trying to figure out, like, I had to take the stupid camera out and throw me off.
My machine. Your human machine. Well, he was West Coast. It was N6.
I was an N6.
You were? Okay. Because in my brain I was thinking you were an N6, and I thought...
Well, I changed my call sign after I bought my house when I decided I was moving to Kentucky.
I see. Okay.
So once I committed to the cell, I said, I've had this call sign for more than 45 years. Time for a change.
Right. So Gus, I'm the official videographer, me and my brother.
I can see, yes.
So
I can tell. You're the official viewer, yes. Good.
Yeah, if we don't get it on video, it didn't happen.
Quite a lot of, you got a lot of job.
It's the old Mythbusters. If we don't write down the numbers, the experiment didn't happen. Right.
You know what I was going to bring was an extension cord, and I didn't bring one.
It's at this stage that Ron begins to set up his equipment. He's got several service monitors, but he brought one today to the actual repeater site where we can actually tune those duplexers that's in the background there that you can see in the corner. And that's the one we use for our 88 2-meter repeater. So he's just in the process of getting this particular service monitor with power, and then we've got to allow it to boot up. It takes about 5 minutes or maybe a little bit more for the service monitor to fully boot up, and then he can begin to connect things to it so that we can begin actually doing some testing. In the background, you can hear Mike helping out Gus and just kind of giving him the lay of the land, which repeaters are in which racks. And as well as what's in the shack. We've got Echolink, All-Star nodes, 440, 2 meters, and other equipment such as packet, DMR, and so on.
So from here they wire up into here, and then from here they wire to here. But I'm going to look
and
at
what model? This is the
IFR 2975.
IFR. Okay.
Yeah, you can buy these on eBay. They used to be a pretty expensive box that you can get them all day long for about $2,500.
Okay, well that's not insignificant, but still.
Yeah, well it's
downloading.
You know it's.
Controller, the config.
How old is that?
When this happens.
Oh, this is old.
30.
Actually, I don't
No,
think right now it's stopped the
maybe
repeater from working. It usually will warn you.
2012.
Oh, okay, so just 13,
No,
12,
it's
13
older
years.
than that. It's
There's a
older,
point
probably
how it's like
2004,
if I re-upload
2005.
everything.
Early 2000s.
So maybe 20 years.
To it if I do a full configuration.
But you know these things here,
it's gonna
when
tell
they
you
break,
at some
you can't
point
get them
by doing
fixed.
this,
You
you're
just go
gonna
buy another
disable
one.
your repeater's functionality.
So I've got a couple of
For the
them
period of time
that
this is down.
you know that are worked and then they died and.
So somebody wants to use.
Can you cannibalize them and maybe get them back?
Yeah, I can cannibalize a couple. What I'll do is I'll just buy another one that may have a problem different than the other two, and then make a good one.
Make a good one.
Yeah, broken, you can get them for $1,000 broken. So I mean,
Because the parts
As
alone
long-
are probably.
yeah. And so this one will die, and then I'll replace it with a different service monitor. I mean, they're buying them used. You can, they're pretty cheap,
Right.
you know. But buying them brand new,
Oh yeah, that's only for big companies
yeah.
or somebody who's in the
Or somebody
fix
who's
it.
got more money than brains to buy a brand new service monitor. Being a ham,
Right,
these are
right,
various
for amateur
functions
radio, I
from
mean,
this
Buy 'em
list of
used.
functions.
They're
you
out
see
there,
I've
easy to
highlighted it.
get,
This number
you
10
know.
is good morning, afternoon, or evening. It's dependent on
And this
the
one
time
I
of
think we used the other day, wasn't it? When we were down in
This is
his
what we
garage.
use.
It's
Yeah, but
gonna
I
say
think
the
there's
date
a
and say
problem
the time, but
with the
not say
tracking
year.
generator. It
So
seemed
if
off.
I had a,
Oh,
So what we're gonna do is we're gonna check the receiver to make sure
if we had a
that we need to actually go into the duplex. We're gonna find out, you know, what it's.
because you checked the sensitivity down in Monticello and thought that was pretty
That
hot.
was a hot receiver, yeah.
Yeah. And I got a feeling this one is because this
Yeah,
picks
it
up
seems
really
to
well.
hear pretty good. It just needs an amplifier put back on the repeater so it'll, you know,
Yeah.
talk out farther. But that's why we think there's a problem with the duplexer, because the amplifier, when it was in service, was causing receiver desync.
It was.
Chunking to chunk to chunk to chunk.
Yeah, it was.
So, you know, when it comes to being a repeater, involved in a repeater group, you gotta have test equipment. And since the club, I don't think, can really afford to buy something like this, you know, I've been doing repeaters forever and ever. And I really believe in having good test equipment, and so spending the money is worth it. I own several repeaters in California still. I'll probably just give them away to hams. There's no point in selling them.
Right.
They're already on frequency. It's just a matter of,
Just the registration.
well, yeah, call up, send a letter to NARC saying NARC is Northern Amateur Repeater Council.
Is
And
that
tell-
similar to the down here?
Yeah, same thing. It's a
Sarah,
coordinating
whatever.
body.
Yeah.
A recognized coordination body, and I'll just send them a letter saying, hey, I've moved, I'm transferring, you know, this over to, you know, whoever, you know, one or several hams that are capable of maintaining it. I'll just
Right.
say, go up to the controller, plug in, put your call sign on the repeater, and do the paperwork.
And this is done all the time because ham radio people get in and out of the hobby. Sometimes people pass away,
Right.
and the repeaters get re-registered or coordinated, if you will, to somebody else.
Correct. And it happens in every state, you know.
In California, it's NARC, N-A-R-C.
Well, Northern California it is. There's another different group in Southern California, and I don't remember what it's called.
California's so huge, I would imagine.
Yeah.
Yeah.
Well, the grapevine divides the state, so
Oh, is it the grapevine that
stuff,
does?
stuff on the other side of the grapevine you don't really hear in the Central Valley. The LA Valley area, that LA basin, you can hear everything down there, but the grapevine is 4,000 feet or more, and your signals just don't propagate.
Right.
All right, so we want to be on, go to our generator mode.
So you press mode, and you're just going through menus.
Yep. And then we're going to hit our frequency.
Uh-huh.
Oops. So our receiver is 146.28.
Yep.
And modulation type is going to be FM. And output generator, we're going to use the other port. We're going to use the TR port, which is right here. And then let's see, M1 is tone 1. And we're going to use CTCCS, PL,
Right.
and then we're going to change it to,
77.
well, actually, let's do this. Let's,
Ron, when you get to that point, this is the kit.
Oh, the
It's
adapter
sitting
kit.
right here.
Okay.
I took it out for you.
And now what we're doing, we're setting up the tone for 3 kilohertz, 1,000 hertz.
1,000 hertz.
I should be hearing tone, not white noise. I don't know what's going on there. What I'm doing is I'm setting up the equipment. I think what I did is I ended up resetting this machine.
Mm-hmm. And once you get this configured and it's working like it's supposed to, you can save that, right? And that way you can bring it up anytime you
it'll
want.
save it, yeah.
Nice. Because there's a lot of options in here.
Yes. Let's see, we can bring the oscilloscope up to full.
Nice. Go for almost full screen.
Yes. You can do that with any of them.
These are so much nicer than what I had in the military.
What you have in the military.
Well, of course, we had the standard oscilloscopes from, the real popular brand, but not cheap.
HP?
The other one.
Tektronix.
Tektronix.
Yeah.
Test, when we still had surface mount stuff, we could test whether or not a resistor was bad, cap was bad, a transistor was bad, just based on the waveforms and stuff. But we never had a service monitor.
Well, depending on what you're dealing with, you might not have needed one.
Exactly.
That's the way. It's just kind of
Yeah, right now
distorted.
it's white now,
but you
just
can
white
see the
noise.
way,
Yep.
the waveform.
Eventually, he'll get a nice,
Yeah.
clean waveform.
Well, I mean, I'm not going to waste the time doing that. We're just going to get it. I don't need to see that.
Mm-hmm.
Oh.
So we'd have to use 146.880 up top, wouldn't we, with that offset?
Yeah, but I'm not going to do it that way. I'm just going to make the offset 0.
Okay.
Okay. Now the pot is right.
Cool.
All right, so is this repeater wired like the other one? You can't hear out the speaker?
Yes, it is, but it's got that.
So you're saying because of how Arcom is handling the receive side, you're going to have to finagle it?
Yes.
Show everybody, when you're like Ron, you got adapters for just about everything, especially the common ones.
This box was buried on the last trip to the hill that we made to Monticello, so we used Don's
Right.
adapters. And so I went digging for stuff I couldn't find and dug it all up.
Right. So now you got your box,
Yeah.
which you would normally use if you were doing repeaters
Right.
that you've done in California.
Yep.
You got your cabling and stuff in your bag that would go with the service monitor. Now we're connecting the service monitor to the receive in on the repeater.
Yes.
There's your tone.
The time is 10.
Now we're going to see what the sensitivity is.
Okay. I'm just going to look over your shoulder. So you're adjusting the dB?
Yeah. We're just going to, since I don't have a sine adder hooked up, we can't measure the sine ad for the receiver. So we're just going to cheat and we're going to see where it breaks squelch. So 123.0 minus 123 is where it breaks squelch. And I'm going to use my radio because turn this off.
Yeah. Turn it on.
Alright, about minus 121
Okay.
is what the receiver, close to the 12 dB quieting point, 12 dB sign add. It's a close approximation. So now what we want to do is we want to check for receiver descents.
121, Ron, would you say is pretty sensitive or pretty average? Or,
It's, well,
or is that
it's-
not really a
it's-
number to
well,
Hang your hat
okay,
on.
for the product, it's probably a good number. But if you put this receiver at a heavy-duty commercial site, it's going to have problems. It doesn't have the selectivity that you would normally expect that it would have.
So then the duplexers really come into play, don't they?
Well, it's not duplexers, it's just a duplexer. And that it, allows duplex transmission on one antenna.
Right.
So we're getting people.
So, it's a sticking point. But I didn't bring that little case in.
We're getting very sick on
I guess I didn't. What I'm doing is I'm going to change these adapters because
So what are these little guys?
this is called a unadapter. It's a universal adapter. This is what we call an RF sampler or an ISO-T. And we put signal in here.
Yeah.
We adjust this, attenuate the signal,
Okay.
and then that isolates the transmitter and the receiver.
So this is a proper one. You didn't have to make it like you did down at Monticello.
Right. Like we did up at Monticello.
Right.
Yes. this
Which
is
what I thought was fascinating how you made that one in a pinch.
Well, we have to be creative when we're hams.
Indeed.
All right. So I know I brought tools with me. Oh man. Cannot break that loose. There we go.
Finally come with you.
It was just very tight. So now it's back to the adapters.
Now we're back in the adapter box, and we're looking for what, an N to 259?
And the PL259. And so what we're going to do is we're going to put this on here like so.
Okay.
And we're going to put this on here like so.
Interesting. That's your ISO-T.
Yep. And then we're going to,
You got B and C coming out of that, and that allows you to connect your test equipment.
yes.
Cool. And then that's going back to the antenna.
Yep. So to do this correctly, what we need to do is we need to find out what the receiver insertion loss is.
Okay.
So what we're going to do is we're going to take the dummy load here.
Right. Got a nice little dummy load there. I'm always amazed at how many adapters you might need.
Actually, the one I want is
And folks, sorry about the camera shifts. We're in a small space, so we're connecting the dummy load to the transmit side of the repeater.
Yes.
Okay, makes sense. And as you can hear, folks, this is a regular work day for us, and we've got Ben out there mowing as usual. Ben loves to do the mowing.
Go ahead and film this where we got the load hooked up to.
Nice. All right, so that's the transmit side, and then here's the
and then the
receive
receiver side is going to the duplexer.
To the duplex.
Now what we want to do is we want to measure the receive sensitivity into the duplexer.
Okay.
So what we want to do is we want to hook up here, find out what our receiver sensitivity is through the duplexer.
So that's as if it were coming from the antenna on
Well,
this side,
Yes.
and you're going to measure it on the other side, which is closest to you. And you're going to see what that loss is.
See if there's any difference.
Right. I'm going to put these two pieces right here. So you're looking, it was 121 and you're seeing a 119 now, right?
Yes. And which is expected.
Yeah, for duplexers, right?
Yeah, so 119.8 minus 121 is 1.2 dB.
That's
so.
not bad at all, is it?
Alright, so now that we know what that is, now we're going to calibrate things.
Okay. That sounds like fun.
Yeah. What I'd like to do is get rid of this stuff and put in some, regular heliacs.
Right.
While Solomon was happening with this.
Okay, so what we've done,
He's up a radio into the
and we've
repeater,
calibrated
and
this
it'll
thing
get
now
into a
to where
cyclic
it breaks
thing,
squelch
just drop and pick up, drop and pick up.
about minus 79. And that's with the 50 ohm load.
Okay.
Now what we're going to do is we're going to check site noise. It's only a valve thing, folks.
Yeah, we do drop checks with Balfangs all the time.
Oh my gosh, I dropped my $20 radio.
Yeah.
Now if that was my FT1 handheld, different story.
Be a little bit different, yeah. So we've seen that it breaks squelch at about, what, did you say, 79,
Well,
81?
it's 79. It was 119.8. Now it's 79, so that's, counted out backwards, so it's
40.
10, 99, 89, 40 dB of isolation.
Right.
So that's worth 10 watts. 40 dB is 10 watts. 40 dBm is 10 watts. So with the isolation of the duplexer, which is an additional whatever it is, 70 dB. Now you've got 40 dB, you got 110 dB of isolation. So no transmit energy will get back into this, which is we want to keep from blowing up our equipment.
Sure.
So now what we're going to do is we're going to plug the antenna in and see how much more signal it takes to break squelch than what it did before.
Interesting. So not a dummy load. Now we're actually plugging in the antenna.
Mm-hmm.
And folks, pay attention to the red box. Sorry, Ron.
Hang on.
Oh, a little bit less.
Yes.
Tiny bit.
Minus 75, 76.
All right, now listen to this. You're going to hear noise come up,
Yeah.
and it'll sound like. I heard a little bit of it in there. Hear that?
Yeah.
That is something else keying up, desensing our receiver.
Interesting.
It's called sight noise.
Okay.
We know it's not our own transmitter because it's on a dummy load.
Right.
So now let's turn it down to weak signal mode. And it could be packet. Let's watch the packet radio and see if it transmits. Now something took it out hard. So the cure for that is to try to find out what's causing the desense. Or we put a real pass cavity on the receive side, which is probably what we're going to have to end up doing.
You think?
So
And
now let's.
When you say a pass cavity, what is that exactly?
These are pseudo pass notch, not a real pass cavity. A real pass cavity has two ports it goes into and it goes out to. Usually they'll give you 20 to 25 dB of an additional suppression with minimal insertion loss, 1 dB. So we'll put a can on here, and then on the output of the going to the receiver, we'll put a preamp and an attenuator to offset the loss of the duplexer and the additional can. So we'll be back at our minus 121 effective receive sensitivity at the receive port through here.
With even more.
Well, what we don't want to put a ton of gain in. We want to overcome losses from cabling and the duplexer and any additional filtering. We just want to overcome that. Because what happens if you put in 20 dB of gain, now you change the dynamic range in the front end of the receiver and it becomes no longer linear and it's not as stable as it should be. And you're picking up noise and you're just shoving it in the receiver. But if you filter out all that other stuff with an attenuator, which is what these are, these are attenuators, and they're graded 10, 9, 8, 3. That's in dB.
Interesting.
So we may put in 12 dB of attenuation.
And what you do is you monitor it, and then you start seeing how much attenuation you need for the sight noise.
Yep.
Nice.
And it is a common practice in the commercial industry.
Yeah.
That's how we keep the receive systems, good.
Clean.
Yeah. So now what we're going to do is we're going to, now that we know what our receive sensitivity is, we're going to kill the receiver, let the transmitter drop, and hook the transmitter back up.
Right.
And see what happens when we key up if the transmitter is adding additional noise to the system.
Okay.
So that's our number right there.
So folks, again, just
So now what
We're
we're
at
doing is
75.
disconnecting the dummy load. Now that we have our baseline of where the receiver is on the antenna,
right.
the sight noise in here is not bad. I have ham sites, 14709 in California has 17 or 18 dB of idle sight noise, and
Wow.
it gets worse from there.
But you've got like a
But that's
ton of
a real
equipment in that
thirsty
room,
game.
don't you?
Well, not in the room, but there's 4 million watts of transmit TV stations up there.
How much?
4 million watts
For
ERP.
real?
Yeah. Yeah, there's a lot of TV stations up on it.
I mean, we got KET right here,
Okay, it's at 3,400 feet. Everybody and their brother and their nephews are up there.
but or up there, right?
All right, so now what we're going to do is we're going to
So again, we've taken the dummy load off the repeater, and we're back to using the antenna.
yes.
Let's summarize what we found.
All right, so what we found is the receiver sensitivity for it's Yaesus are hot,
Okay.
so we can't get away from that. The loss through the duplexer is about 1.2 dB, which is expected. It's as good as the Monticello.
Okay.
Okay, that I tuned up. And we'll retest that one because I wasn't sure about this tracking generator, and I wasn't going to mess with it anymore because I knew I was going to tune it when we got it on site with a different piece of test equipment.
Okay.
So it's not complete. You know, I didn't check for insertion loss. Well, I checked insertion loss, but I didn't check the return loss, the SWR. And it's possible that you can have a perfect pass, low insertion loss, and a high SWR.
Right.
And you tune the cans to bring down the return loss. So you want to see, you know, better than minus 13 dBm on the return loss.
Oh, okay.
Yeah, because that's 1.5.
So for here, you got the 1.2 of the duplexer.
Yep.
High sensitivity on
Yep.
the repeater. And sight
3
noise
dB
of about
sight noise.
3
Now,
dB.
what that sight noise is, what that means is when we do our sight noise test, we have to use an additional 3 dB of signal coming in, you know,
To overwhelm that noise.
to overwhelm the noise that's at the site.
Okay.
There's always noise on radio signal. It's always there. On HF, you see it in the form of an S meter movement.
Yeah.
On FM, you cannot see that, but you can hear it in the receiver.
Okay.
So we know there's 3 dB of sight noise, and there's an additional noise that comes up randomly that probably adds another 2 or 3 dB on top of that of additional noise, which causes the degradation in the receiver sensitivity. So what we'll do is we'll use one of these
And these
attenuators with,
an attenuator.
with a can,
Cool.
you know, a filter can.
Uh-huh.
You know, the antenna will go into the can, the output of the can will go into a preamp, and the output of the preamp will go into this, and then this will feed a 50 ohm input to the receiver.
Interesting.
Yeah.
Cool.
And because you want to keep your noise in front of the preamp as low as possible.
As low as possible.
Because you have an additional noise that we're going to overcome with the preamp.
Right.
On FM, it's not as much of an issue because it's works much differently than demodulating sideband or CW or AM. You know, you've got noise. FM's receivers are noisy anyway.
Interesting.
That's why when you crack the squelch, you hear the noise in the speaker.
Mm.
That's noise generated in the intermittent frequency chain of the receiver, and it comes out as white noise.
So this little doohickey, you call that again
An attenuator. And what we'll do is it'll take the gain of the preamp. Say the preamp is 20 dB gain,
Okay.
and we want to overcome these losses and all the system losses and the sight noise. Well, the sight noise will always be there, but hopefully we can pump up the weak signals enough so it will still get through anyway. But the filter will filter out any additional noise that's out of band, unless that noise is really close to us in frequency.
Right.
You know, that can is pretty. It's got a pretty sharp skirt on it, and so the skirt is this. Just bring it. Show the folks what a skirt is. The skirt is from this point to that point.
Right.
That's the bandwidth of the signal. That's called the skirts. And so you'll see that when we put the cans on the other piece of equipment, what the skirts are.
Okay.
And so,
So you've got a couple of these, 2 or 3 of these attenuators, and
well,
we're
I got
gonna-
a box full of different
right.
sizes.
You've got several of them, and you'll use these to test, right?
Yeah.
Cool.
So, and we'll find out what the value needs to be. And these are just things that radio technicians should be carrying with them, attenuators.
Right.
And these are production. These are test.
Okay.
Because
so
they're
these are
DNC.
highly accurate.
Well, they're as accurate as this, but these are made for quick disconnect in and out for measuring. This is for putting permanently in place.
Right, because they've got different ends on them, right?
Yes.
Yeah. All right. Well, folks, we'll bring you right back in just a moment. So, Ron, again, this is the isolation
Well,
T.
right. We call it a signal sampler
Okay.
made by RF Communications.
And this is what you built at Monticello.
Right. I built the field version of this.
Right, yeah, which, quick and dirty. But you were just telling me off camera, how much is this?
Yeah, they're about $100.
Wow.
The one I really like made by Bird is $150 to $300.
Working it.
All right, Ron. So now we're setting up on the old spectrum analyzer here. What function?
We are setting up the tracking generator.
Tracking generator.
Yep.
And how does this help us?
Well, this lets us see what we're doing as far as transmit insertion loss and receive insertion loss, and the basic overall tuning of the duplexer.
Okay. Right now, folks, he's just plugging in his frequencies and things of that nature. Get it up and running. For
The
that.
markers.
Yeah. This unit has pretty good functionality when it comes to the markers, so you can see where you're at.
Yeah.
That vertical line that you see there, actually two verticals, are markers.
So our output is on the tracking generator. So what I want to do, I think I want to turn off that attenuator in the receiver. So we're going to come down here. It still shows that I'm minus 10.
Yeah, it does.
Yeah, so we're going to leave it that, and know that that's our point.
Okay. So what you've done now is you've hooked up the two leads.
But see, according to this, our cans are off. Quite a bit.
So we're looking for a good downward spike there. aren't we?
We're looking for a hump. Because that's where our notch is.
Right.
I'm going to swap out a cable. Because
Okay.
something doesn't seem right.
Doesn't seem right.
No.
All right. Well, we'll bring them back.
Because when I first plugged this in,
Yeah.
it was different, and then I jacked up the receiver, the cans. Yeah, those cans don't look like they want to tune right. Let me do this. I'm not going to mess with this side. Tune one can at a time and find out if we can.
So this is literally just a single cam.
Yeah. So that one looks like it's okay. Okay, 0.7. Alright, that's good.
We saw 1.2 with the pair, so we would expect 0.5 ish.
Well, there's cabling losses, so
Oh, true.
that we're not being taken into account for. So let's do this.
Okay.
So 1.7. But see, our notches are a little off.
And what do these little glass or rods do on the side of
These adjust the notch.
the notch? Okay.
See how that
Oh
moves?
wow! Look at that baby. Now we're getting a better notch.
Well, we want it to be on the line.
Correct. Oh wow! Look at that thing, Ron.
Yeah, but see, now when I hook the other side up,
Yeah.
it's going to change, and that's where the problem is.
Well, that's better than it was. Because you want it to get deeper as you can, right?
Yes.
As well as on the line. That's better than it was. Significant. Well, I don't know about significant, but it was several dB.
So, that doesn't actually look too bad.
And would that a little bit of adjustment make a difference as far as how well it would tune out the sight noise, or is that totally separate?
Well, there's two different things there. We want the duplexer to be as much isolation, notch, and as low as insertion loss as we can
Absolutely.
arrange. And we put a 50 ohm load on the other side so we get terminated port.
This is on the transmit side.
This is the receive side.
Sorry. That notch looks pretty good.
Yeah, that notch is pretty good.
That's about where the receive was.
Yeah,
I'm looking at it on the same scale.
that's right. That's how it's supposed to be.
Okay. Maybe a teeny bit better, but not by much.
Well-
But your receive wasn't nearly as good as what you got, and now they look almost identical.
Well, there are some differences. You see, this here is a little off.
Okay. Doesn't take much, does it?
Mm-hmm.
There you go.
I don't want to mess with the notches.
Right.
So what I did is I tuned it up so the receive loss and the transmit loss is the same,
Right.
1.6. But our pass
Is that what
was-
we're looking at down here in the red box?
Well, no. That is how the signal level.
Okay.
What we're looking for is the bottom of this line for the notch
Oh, okay.
and the top of that line for the pass.
Nice.
But we're going to be picking up better signal on the off the repeater because at 2.3, 2.4 insertion loss, you're approaching closer to that 50% loss in power.
Wow. So basically, for what we came up here to do today, are you pretty happy with the outcome? Or basically from a knowledge standpoint, because now you know where everything stands.
Yeah, the duplexer was off a little bit. It wasn't off enough to cause degradation, but it still was enough to affect the transmit power output.
Right. And we know what our sight noise is now.
Yes.
We've never known that,
Yeah.
to my knowledge. So now that we've got these numbers, really probably the next time we come up here, are we looking at one of the filters?
Well,
Or attenuators?
the filter is about the size of one of those bottles in that. I mean, they're big.
They're big.
They're big.
But the attenuator, my apologies, that you were talking about.
Well, the attenuators are those little things.
Right. And then a preamp.
Yeah. Preamp is a little different. You know, it's a square box, basically.
Yeah. Well, that could be the next time we come up here.
I gotta find out which box they're in.
They're in, yeah. Keep in
I've
mind,
got
folks,
several
Ron
of
moved from
those.
California, so he's still got a lot of stuff in boxes.
Yeah. And I have something called a return loss bridge that would work with this. It would give me a different kind of a reading on these cans.
Okay. But a lot of good information today.
Well, we got a baseline of the site. We know what's what.
Exactly. And we can just start tackling them, you know, just ticking off the checklist. Ron, we want to thank you for your expertise on all of
Well,
this.
don't thank me yet. We gotta wait and see what's going to happen out in the field when
Right,
you guys are starting to use it.
right.
So what we need to do is come in and power everything back up again.
Okay. And for all intents and purposes, we'll be done for today.
Yeah, hopefully.
As long as everything works. But it probably will. Nice.
And for RLS testing. Anybody around can substitute this.
And folks, for now, that will wrap things up. For the Lake Cumberland Amateur Radio Association, I'm KY4BDP with N4RLS, and we'll bring you more videos similar to this on how you can optimize your shack. Wave! No.
Why would he want to come up there? Brian always wants to get up the tower.
I don't mind.
Just not exactly prepared for it today.
No. I would have worn different shoes.
And probably some pants too.
Yeah.
Piece of plastic. Almost hit you, Brian.